If you're watching this video, I'm pretty sure that you had the chance to mess around with language models as well as APIs that involve language models, such as OpenAI APIs. And I'm also pretty sure that you've given before a task to a language model just for it to retrieve you an output that was either inaccurate or something completely different to what you were asking for, right? And believe it or not, this is a skill, the skill of writing a prompt effectively, right? Or as many people call it, prompt engineering. And that's what I want to talk about today in this video, okay? I want to go through the importance of prompt engineering, and also I'm going to give you a framework so that you can use in whatever scenario without the need of any prompt templates, so that you can write an effective prompt in whatever scenario you are. If that sounds interesting, let's get straight to it. All right, so I created this little presentation to accompany what I will discuss today, obviously prompt engineering. And before we move forward, I want to clarify once and for all what this is. So we're basically giving an input to a language model and we're expecting an output. But as I discussed before, the output might not always be what you want. So prompt engineering is the process of refining and iterating on that initial input to get an input that is good enough so that when we give it to a language model, we get the output that we want without the need of fine-tuning. All right. I'll leave fine-tuning outside of the topic of today's discussion, but I suggest you search it up if you're curious. All right. So why do we do prompt engineering? Well, part of the reason is because we treat LLMs as black boxes. We don't exactly know how they work. They're rather complex. We do know that they're made of neural networks in order to predict an output. But that's the thing. It predicts an output. So you might give an output with 90% certainty, but that 10% is still unknown. All right. So the process for language models on generating outputs is not fully understood. This is a typical black box problem that people encounter in science, right? There's other mechanisms that can be treated as black boxes as well. And luckily enough, there is a method to which we handle these types of scenarios, right? What we do is we place in an input, we get an output, right? Output 2. Then we place a third input and we see that we get the same output as when we put input 2. And therefore, we can start making relationships out of them, right? In order to find how the language model performs on certain scenarios or certain inputs, okay? And this scientific method of evaluating and measuring how language models perform is called benchmarking. And that's, I don't know if you're aware, but there's some evaluation parameters. I don't know if you saw human eval, which is a benchmark that OpenAI uses to test the performance of language models. They basically do this, right? They give a certain scenario with the input, and then they observe what the output looks like. And then they measure, right, with all the relationships that they get from the different inputs, how well the language model performs to certain scenarios, okay? So that's why it's important to do prompt engineering, simply because of the unknown mechanics of a language model, right? We treat it as a black box. And researchers use benchmarking to understand what the LLMs are capable of, right? Their strengths, weaknesses, and just their overall performance in handling some specific tasks. You might have probably seen one of these metrics, right? It's called human eval. It was created by OpenAI to measure the performance of language models in code. So we give it the same instruction to generate a certain code, and we have all these different models try to generate this code given that task, right? And therefore, this is a method to see the performance of different language models, right? You're giving it the same input, and then you're measuring the output of the different models and see the output which is closest to the answer that you're looking for, right? Now, stepping aside to benchmarking, we're coming back again to prompting. So the two aspects of prompting. These are the two typical ways of prompting a language model, right? We have conversational, which is your day-to-day ChatGPT conversation, right? It's manual. You need to make follow-up prompts because it usually doesn't get the first answer right when it's a slightly more complex task, right? You need to keep chatting to a language model until you get the best output possible. And this is good for personal use. This is amazing, right? This is all you need for personal use. And then on the other side, we have zero shot, which is basically just giving it an input and getting an output out. This is ideal for AI power systems because with these automated systems that involve language models, we can't add a human in the loop, okay? We can't add a human to constantly update the output, right? This is all automated. That's the whole point of it. And therefore, there's no follow-up prompts, as I said. You cannot correct the output. And this is the reason why good prompting is important, right? So we see the benefits, that it speeds up your work output on conversational. But the great benefit with the zero shot is that you can build very powerful systems for companies to save them time or increase their revenue, right? And this could be worth thousands and thousands of dollars. To further reiterate, further explain the importance of this, I don't want you to listen to me. I want you to listen to this guy. Who's this guy? Well, you can see that he's the co-founder of OpenAI. He's the AI director at Tesla. I don't know if this is up to date, but he was at some point, right? So gotta listen to this guy. And he did mention in one of his tweets that the hottest new programming language is English. Programming in natural language. So supporting on what Andrzej said, I don't want to butcher his name, but there you go. So supporting what he said, we are able to observe over time how code has evolved, right? How programming has evolved. At the start in the 80s, we had people hard coding everything in Fortran, for example, the old school code, one of the first programming languages ever invented. And then over time, we realized that we could wrap the same code that would be used for a specific task. We could wrap that into functions so that we don't have to create the same lines of code all the time. And then functions and classes could be built into libraries. And then libraries could be built into entire frameworks, all right? In order to allow for the programmer to make their life easier when it comes to programming, right? So that they don't have to hard code everything again. And then very recently, we started to add visual tools to it, right? Such as Webflow, so a website builder that allows us to build websites using no code, right? Using visual tools. So all these visual elements represent HTML, CSS, and JavaScript code in the background, but we don't even have to see that because it's all handled by the UI. And if you're able to observe how we've made programming simpler, right? You should be able to see that the next logical step is to move from visual tools to natural language, right? Instead of using a visual tool to build a web app, for example, like I've shown here, you can, at some point, I'm not really sure, I'm just speculating, but at some point we should be able to see programs in which you can write natural language. For example, build me a web app, and it will build a web app for you just by giving it a good prompt. So what am I saying all this? Well, this is because the logical pathway forward is so that at some point we will be able to program everything using natural language. That's why knowing how to instruct language models to do these tasks is very important. And once again, you might not believe what Andrzej has mentioned, but I can show you another YouTube video from NVIDIA CEO.
And that the programming language is human. Everybody in the world is now a programmer. This is the miracle. This is the miracle of artificial intelligence. For the very first time, we have closed the gap, the technology divide.
Right. And this guy was at a conference with thousands and thousands of people. And these people that are talking about it, they're not some random person in the street. They are industry leaders, right? And they have a lot of experience and have a lot of exposure with people that are actively researching in AI. So to be honest, I would listen to them, right? Because they have much more insights than us. Once again, I'm reinstating the importance of prompt engineering, basically because it's involved in all language models. So they basically, all of the systems that you're making right now, that you're playing around with, including the ones that I am building, involve language models, right? It's all coming from the basis of knowing how to write a good prompt. Okay, and for those of you that don't know how to program, we even see it in code, right? It's everywhere, anywhere that involves a language model involves a prompt, once again. All right, Frank, then how do I learn how to prompt properly? Well, you use frameworks backed by research, all right? And this goes with anything that you learn online. Don't believe what everybody tells you. Do some research in the topics that you're really interested in and really find useful, and make sure that most of it is backed by research. And that's what I'm going to show you today, right? You will learn a framework that is backed by research in order for you to write prompts effectively. And also I'm going to teach you techniques that you can apply to your prompts, to this framework, in order to increase the accuracy of the output, all right? I will also make you think like an engineer when you approach problems with this framework, okay? Engineers use frameworks to solve problems. And also with prompt engineering, you're able to achieve the same performance as you would with a better model, such as GPT-4, with cheaper models, such as GPT 3.5. All right, and this is the framework, okay? This framework is used to build systems, okay? Automated systems, right? This is not related to the conversational part of prompting. It's more related to how can you write prompts that would fall inside a larger automated system, all right? And this framework, you can carry this framework to whatever scenario you need that involves prompting and a language model, okay? And it's divided into different framework items, which I will discuss later on. Inside each of these framework items, you can add some techniques to increase the performance of the output, okay? And all of these result, as I said, in a performance increase on the output, which we can quantify, and you will find out later on the video how much these values are, all right? Let's put an example, all right? I've actually built something very similar to this, so I will leave a link in one of the top corners so that you can see that video if you're interested. And in that video, basically, I write a prompt. And this prompt will be added here, all right? So what happens here is that I make a call, all right? I make an outbound call, right? Someone fills in a form, the call is made, then the audio is sent to a language model, and then a transcript is made. But we want to control this section where the language model decides whether the lead was qualified, not qualified, or it needs further review from someone human. This is where the prompt will be. Let's explore that. Typical prompt will look something like this. Classify the following transcript into one of the three categories, right? And then you add the transcript. This is added in dynamically. If you've seen other videos that I made, especially on Make, you will see that I add a variable because the transcript can change depending on the call, right? Every call will have a different transcript, obviously. And what we do is that we use the system role. So let's rewrite the prompt using the first framework item. So basically, system role is first part of the prompt where you define a role for the language model, okay? For example, you're a highly skilled and meticulous transcription classifier with ability to accurately and so on and so on. You place in this technique called role play. So you are assigning a role to the language model. And this basically helps the model get into the task a bit more. And there are two things that you can add here. So obviously the role, which in this case will be the highly skilled and meticulous transcription classifier. And then you can add the additional descriptions, right? This helps emphasize any specific tasks that it needs to do, right? So if you want it to be good at classifying leads, well, you add some additional descriptions so that you emphasize how good it has to be, that task, right? And what people have found, what researchers have found, is that when you add a role that is favorable to the task that you need to do, you can increase the output by 10.3%. And adding additional descriptions for small language models increase the accuracy or the performance by 20 and 50% for language models, for larger models. So the things that you have to remember from this is that you have to, for this section, you have to instruct the model to play a role, to perform a task. So you're a physics teacher and you're going to solve physics problems. And further tip would be to give it a persona, right? If it's solving relativity problems in physics, you tell it to act like Albert Einstein, right? If it's solving problems with black holes, for example, tell it to be Stephen Hawking, right? And of course, you will place additional descriptions to let the language model understand how good it is at performing the task, right? So you're kind of motivating the language model a bit. All right, so this task was the task that normal people will write, right? But beforehand, you will write the system role, and that's how it looks. I added this just to emphasize that we are missing the system role here, right? And then if we add a self-consistency technique, which means that in the prompt, in the chain of thought prompting, we also give it different perspectives of how to approach the answer, we can further increase the performance by 12.2 to 18%, okay? And things that you have to remember is that chain of thought only works well with language models with more than 100 billion parameters, okay? So the larger the model, the better the performance. And the more complex the problem, the better the performance when we use chain of thought, okay? Now let's add this onto the full prompt, and this is how it would look, right? So we're changing this simple looking task, right? And we're adding the whole thing, okay? The whole thing that we were talking about before, right? The well-structured task prompt. All right, so now we're getting onto the third framework item, okay? S and C basically stands for specifics and context. I put them both in the same item because they involve the same technique and they kind of also overlap each other. Okay, but specifics are short descriptions of the importance, the value, and or the impact of the task, okay? And context, you're giving it a general description of the environment the LLM is doing the tasking, okay? And once again, how doing the task will benefit the user or whatever or whoever the user refers to. And with context, you can add a bit of role prompting techniques, okay? The main technique though on this framework item is emotional prompt. So you are hyping the language model up, okay? By adding phrases or sentences that contain emotional stimuli, right? So we're hyping the language model to increase the performance of it. Okay, here are a few examples. So this is very important to my career. It's vital to my career. I greatly value your analysis. Take pride in your work, give it your best, and so on, right? Hyping the language model up. And researchers have found that we can increase the performance of it from 8% for simple tasks up to 115% on complex tasks, right? So you can see it works well with complex tasks, right? And we get a further 10.9% improvement in these areas, right? All right, so we can apply this to an example, all right? And let's use the technique we were mentioning before, right? Emotion prompt. So stimulating or hyping up the language model through the prompt. We're saying that the task is important to the success of our agency. Proper classification is crucial for following out actions and enhancing the business efficiency, right? So we're giving a context to why the task is important. Not only that the task is important, but why, all right? And then we give it some context, okay? So we are adding role prompting technique here. So we are mentioning the role, right? And we're saying again, it's essential for our sales team to prioritize leads and improve follow-up process, right? By doing certain things, you're contributing massively to the growth of our agency. Thus, we deeply value your attention to detail in this task, right? Hyping the model up. That's all this is, okay? Right, things to remember. So for specifics, you will add simple phrases to push the model to be a bit more deliberate, right? Especially for complex tasks, which require very careful consideration, okay? Don't waffle. That's the point of this. Don't waffle. Be straight to the point to what the specifics are, okay? For the context, make sure you inform the model what is your business, what services you offer, what products you sell by. Be very specific, right? As once again, don't put any waffle, okay? But describe as much as possible regarding the context, okay? You can describe the system the model is a part of as well. So you're part of a transcript system, right? So it's able to understand the surroundings in which the model is involved in. And once again, you should portray the importance of the task, how much impact it has as well, okay? Things to remember for for this third framework item. All right, let's add it into the full prompt, and it will look something like this, okay? Specific context here, as well as all the other things that we talked about. All right, so now we get onto the fourth framework item, which is examples, right? Providing the language model with examples, okay? And what most people do is that they provide a task and then they provide some form of example, which is usually vague, all right? And there's a difference between a vague example and a well-structured example, okay? And this affects the performance of the language model, okay? So the way you should do this is structure your examples as input-output pairs or question-answer pairs, right? First of all, you would put the query that you would ask to the language model. And then as an answer, you put the output that you desire, you want to see from the language model, okay? And this increases the performance of the language model because what you're basically doing is that via the question answer pairs, you're allowing the model to make connections to the examples, right? In a very structured way, so that when you place in an input on the language model, it's going to search on that example that you gave it. And if the input that you gave is very similar to the input from one of the examples, it's going to try and generate the output that appears in the example, right? So that's what it is. And the technique that you have to apply here, right, for making these examples, apart from obviously structuring it in a question answer pair, is basically giving it more than one example. That's what this technique is, right? The few shot prompting. Zero shot prompting is giving it no examples. One shot prompting is giving it one example, and few shot is giving it more than one example or question answer pair, okay? And there's a big difference between no examples to one example, and also there's a big difference between one example and more than one example, okay? Which is what I'm trying to emphasize here, right? And the thing with few shot prompting is that it's a great alternative to fine tuning, given the accuracy increase that you get versus the effort that you have to put in to make it happen, right? For example, fine tune gives far superior accuracy increase compared to few shot prompting, but it does require a little bit of effort, right? Nowadays, it doesn't require that much effort because there's services in place to help you fine tune, but nevertheless, you still have to put in some thought when fine tuning, right? You have to know what you're doing. But few shot prompting is so easy. It's literally just adding a few examples, right? A few question answer pairs. And with only that, you already get a significant increase in accuracy, right? There you go. And we can see this in the research findings, right? Compared to zero shot prompting, we get an increase of 26.28 or 47.43, right? All these metrics, by the way, are lower bounds, right? I like to be pessimistic with these metrics, right? I want you to get the minimum available increase in accuracy, because some other videos put a large number, right? A large increase in accuracy, but I don't think it's the way to measure this, right? It's not always true that you're going to get the highest ranges of accuracy, right? It's better to be pessimistic and then expect the least accuracy increase, and then, you know, work from there. This graph supports what I was mentioning before, right? So we have here zero shot, so no examples in the prompt. Then you have one example in the prompt, and we have more than one example in the prompt, right? This is the most significant increase, but you have to acknowledge that this is also an increase by just adding a few more examples, right? And you can get to the point where you reach 67% of accuracy, right? With models that have 175 billion parameters, right? These are the typical models that you will be playing with, not these, okay? This is more common. Right, now we have some examples. So this is pretty straightforward, right? They're just giving out different scenarios, right? Like different questions and answers, right? So this should be not qualified, this is qualified, this needs checking, right? In scenarios like these, I would put in more than one question answer pair for not qualified, qualified, and needs checking, right? More than one for each scenario. And these are a couple tips that you should remember, okay? So the first one is the examples that you're going to give it, okay? Make sure that you give the language model the most rare and confusing examples, okay? Because language models are already fed with general examples, okay? So if you give it the most rare and confusing examples, it's going to be ready for all types of scenarios, okay? All types of examples, right? If you're giving it only the general portion, then it's going to miss the rare portion, right? So you want to give it all of the types of examples possible for that scenario, okay? And it has been proven to increase the accuracy as well, okay? So I'm not just waffling, right? This is actually true. It increases the accuracy, right? And make sure to stay within 10 to 30 well-formed examples, okay? To hit that spot with a maximum accuracy increase. And then we get onto the full prompt. Well, not full prompt because we're gonna add something else, but this is how it looks so far. Okay, system role, task, specifics, context, and examples. Okay, great. All right, so now we get to the fifth and final framework item, which is the reminders item, okay? And why do we do reminders? Well, it's due to an effect called lost in the middle. So what happens when you give long contexts to language models? Well, what tends to happen is that the language model tends to forget what's going on in the middle, okay? So the reminder section is there to remind the language model about any facts or figures or anything specific that it needs in order to get the output that you want, right? So I call it an iterative section, okay? Iterative because you can use this to correct what the language model didn't get right, okay? And I explain it here. So the reminder section starts small and then increases in length after more test runs in order to tweak the output after every test run, right? So the reminder section starts small and then you're gonna catch the language model doing other mistakes. So you're gonna keep adding reminders until it doesn't do any crazy mistakes, okay, in the output. And I talked about this here already. You're gonna see this now, right? This is a visual representation of the lost in the middle effect, okay? You're gonna see that now. And yeah, well, this is an example of the reminder section, right? So in case it forgets, provide only the classification label, right? Because it might not only say qualified or not qualified, it might say, this transcript shows that it's qualified. You don't want that part, you only want the word qualified. Sometimes it forgets, so you gotta remind it to only mention qualified or not qualified. Or, well, there was actually another one, but you get the idea, right? And also, if uncertain about the classification, prioritize caution by assigning the qualified label, right? So if we see at a point where we don't want it to say qualified or not qualified, we can change it on the reminder section, okay? And we've seen that at least we get a 12% accuracy increase, okay? As I said before, this is the minimum amount, okay? It could range from 12% all the way up to 50% plus, right? There you go. And here we go. So this is the lost in the middle effect, right? So we're basically putting, let's say around 20 documents, right? And through these 20 documents, you see that it's starting to lose accuracy at retrieving documents between the 5th and around the 16th document, right? Or so on, right? It's really good at getting all the context from the first documents that you added and also from the last documents, but it's really bad at retrieving the documents in the middle, okay? All right, so tips to remember. Instructions given at the start and at the end of the prompt are more likely to be remembered by the model than in the middle, okay? So put the most important things at the start, at the end, and at the end, okay? As I said again, use the reminder section after you have already tested the output a few times, okay? So only put these in the framework, okay? Test the prompt, right? Get an output from the language model. And then if you forget something important that you want to include, then that's when you start creating the reminders item, okay? And yeah, adding more context won't cause better performance, okay? Remember that. So if you can get this framework as short as possible, the better, okay? Because the effect of lost in the middle will be less, okay? So don't waffle, okay? Don't add any unnecessary fluff. Make the prompt framework, okay? All of the single things that you're putting here, right? This whole framework, all of the items, make it as concise as possible, okay? Because language models are really bad at long contexts, right? So don't forget that. Right, so this is an example for the reminder section again, right? I think here I corrected it, right? Added an each checking label. And this is how the full prompt looks like, right? From start to finish. As I said again, if you can make it shorter, that's better, okay? Try to keep it as short as possible, right? With as less fluff as possible. All right, so here you have, this is the performance increase of each, right? As I said again, this is a lower bound, right? With these kind of things, I don't like putting a higher bound, okay? I like making it lower bound because that's the minimum increase in performance that we can be expecting, right? I don't wanna hype this up and say, oh, okay, well, it's a 90% increase, and then you test it out and then you see it's actually not, okay? So for these scenarios, it's always better to get the lower bound, okay? To not get overhyped for something. Okay, and the total is a minimum, okay, a lower bound of 149.7%, okay? That is the minimum performance increase that you're going to get by adding this prompt framework, okay? I've done tests myself with a couple language models, right? I think I've done it actually using 3.5 Turbo and Opus as well. And I've got an increase of around 250%, okay? So it can vary a lot, but I'd rather give you the lower bound results so that you don't feel too optimistic about it, okay? Because it really varies on different scenarios, okay? It varies depending on the scenario. Therefore, I don't want to hype you up, okay? But try it out, test it out, and see if this framework works for your use case, okay? Markdown, okay, something very important as well, okay? This is more for organizing your content, okay? To give you a bit of a structure when you write a long prompt, right? So people have seen that OpenAI uses Markdown in crafting their prompts, okay? There's tweets out there that mention this, okay? And it could be possible that they use it in their training data sets, all right? The whole point of adding Markdown is more for you than for the language model, okay? It just improves how legible the prompts are, okay? And it doesn't affect the performance of the model either, okay? So to get started with Markdown, you can add heading 1, heading 2, heading 3 tags like you would with HTML, right? Or if you don't know what these headings are, you literally go to Word or Outlook or whatever, and you'll see how the hierarchy works, right? Primary heading, secondary heading, tertiary headings, and you can add bold words as well, okay? These are the only ones that I recommend to start with, okay? To not overcomplicate it. And now I've provided here a difference, okay? So you see here how I'm separated with a space, right? I'm not emphasizing anything. This is just plain text, but over here, we are letting the language model know, and also ourselves, right? How are we separating the sections of the prompt, right? Okay, as you see here. Okay, hope that makes sense and I didn't overcomplicate that. And these are the references, okay? Just for you to let you know that I'm not fluffing, okay? All this that I have discussed in this video is backed by the research you see here, okay? So feel free to have a look and comment down below in the description if you have any doubts about anything that I've mentioned, okay? All right, so now you should be armed with a pretty solid prompt engineering framework that you can use in any use case or scenario without the need of downloading a prompt template, all right? So go give it a shot, all right? Try with different language models and come back to this video, drop a comment and let me know what you think about it, all right? If you like this video, please give me a thumbs up and give me a follow if you want to see more videos like these, all right? And if you didn't like the video, drop a comment down below and let me know why, all right? And that's pretty much it, all right? Enjoy the rest of your day and I'll see you in the next one.